Let's start at the beginning and talk about design patterns and who the heck are the Gang of Four. Many years ago, I went to a course about designing software. This was back in the Windows 3.1 days, and Windows had a tremendous selection of colors. It had black and white and gray. It also had certain important design standards. The File menu was on the left, the Help menu was on the right. It also had some other standards. The OK button was on the left, the Cancel button was on the right, at the bottom of the screen. And if you think back to those old Windows apps, if you've ever seen one, they're really pretty simple and they follow very simple basic patterns. But yet the first line of the course was Designing Software is Hard. And they showed all sorts of examples of people who had messed up usability in Windows 3.1 apps. Well, since that time, we've had the web. And the web broke all of those interesting user interface design rules that I had learned. It used colors. And Mac and Windows can't agree as to which side the OK button should be on, and websites can't agree either. So now we have design patterns. And design patterns aren't used particularly for user interface designs. I use that as an example. Designing reusable object-oriented software is also hard. As software has grown in complexity, it's also gotten harder to write good software. Design patterns help us write good software because what we're going to be using are patterns that have demonstrated a proven success over the years. So our software designs should address our immediate problem, obviously. We hope that they should also be flexible for future problems, or expansions, or features, or at least they won't inhibit those future expansions because we've designed ourselves into a box. We would also like to reuse things that have been proven to work. And these are the patterns that we're talking about. They're effectively building blocks of code. Now, we're not talking about copying and pasting our favorite pieces of code. We're talking about the patterns that build that kind of successful code. And we don't really need to reinvent the wheel. If someone has created a pattern that solves a problem that we have, then we don't really need to create our own solution, unless, of course, their pattern just isn't any good. The design patterns that we're going to talk about in this course have been proven over time, and they also solve really common architecture problems in software. A pattern addresses a common problem. So if we have, for instance, a problem that we have complex objects to create, and we don't want to spread all of that complex construction all over our application, that's a pattern. It's called the builder pattern, and we'll be taking a look at it. It's a template or a guide. It's not a final design. So when I talk about a builder pattern, we're going to be talking in general terms. We'll give you concrete examples, but the builder pattern can be applied to all sorts of different kinds of software. It can be applied to mobile. It can be applied to web or desktop. It can be applied to different languages as well. We're going to focus on C#, but these patterns were written prior to the existence of C#. They're really design patterns as opposed to language patterns. We're going to do some C# implementations of those patterns, but the ideas behind the patterns are the same. The pattern doesn't describe classes. It actually describes relationships, interactions between classes. The classes that you create are going to be particular to the application that you're creating. You may have customer classes. You may have measurement classes or graph classes or document classes. Patterns don't talk about those kinds of things and the specifics within the classes. It talks about how the classes relate and work with each other. The patterns aren't architectural either, so it's not an entire application architecture. For instance, you might be familiar with three-tier architecture or MVC architecture. The patterns that we're going to talk about in design patterns are smaller in scope than that. They're actually little pieces of that overall architecture. Now, later on in the course, we will talk about more global architecture issues as well, and including we'll spend some time on MVC. A design pattern has 4 elements. It has a name. I hope that's self-explanatory. It also describes the problem to be addressed. And when we talk about each one of these patterns, we're going to start with what's the problem, because that's really what's going to happen in your practical usage. You're going to be presented with an application or part of an application that you have to build, essentially a problem. So you want to be able to recognize within that application what patterns, if any, that you should use. So we'll start with the problem, and then we'll talk about the pattern that may address that problem. So after we've talked about the problem, we'll talk about the pattern that provides a solution. And then we'll talk a bit about the consequences of that. Hopefully, most of the consequences are positive. For instance, it makes our application much more readable and simple to use. There may be some performance consequences here and there as well. So a quick example. Here's our problem. We need to support multiple database types. Sure, we're going to start out with a little bit of a MySQL database for this application, but we expect it to grow like gangbusters. And we know that we're going to need to be able to expand it to something that uses a huge server farm and probably Oracle servers. So we don't want MySQL classes spread all over the code, because when we expand to Oracle, and that's going to happen quick because we're going to go viral, when we expand to Oracle, we're going to need to make the change really quickly. So we don't want MySQL classes spread all over the application. We want them isolated into one particular area. So we can use a pattern called an abstract factory. And what that does is it provides an abstract database class. It's not a MySQL database class. It's not an Oracle database class. It's not a SQL Server database class. It's really kind of a generic database class. And then our factory will create an instance of the particular database type that we need. So today, we'll create an instance of a MySQL database. But in the future, we'll be able to create an instance of an Oracle database, and both of those classes will descend from this abstract database class. And the entire rest of the application won't change a bit, because they won't know anything about MySQL or Oracle. They'll only know about our abstract database class. So that's the kind of pattern that we're talking about. We've presented a problem, and then we come up with a pattern that has already been proven out that solves that problem. What's this Gang of Four thing that we keep on hearing about? The Gang of Four are Eric Gamma, Richard Helm, Ralph Johnson, and John Vlasides. And they wrote a classic text called Design Patterns, Elements of Reusable Object-Oriented Software in 1995. So it's about a 20-year-old book, but yet it's still a classic and still well used. And of course, you can get it at that Amazon link. And it describes 23 different design patterns that are commonly used in building software. And we're going to go through each one of those 23 patterns in this course. And we'll first describe the problems and solutions and a little bit about the pattern and the class diagram to show you the interactions between classes. And then we'll do some code examples of each one of the patterns in C# so you can actually see them in use.